Hello Year 10, welcome to this next lesson. So today what we're going to do is logarithmic graphs. What you've done in the previous lesson is you have been introduced into logs as a number. So we're going to draw that into a picture today. So the basic form of a log that you guys see is usually y equals to log ax, where a can be any number or constant. Yes, and we're going to write any constant. We're going to do an example. So for example, we have y equals to log base 3x. Now, before we start drawing into this, we're going to look at some features about it. We know this equation from previous topics that this here is an exponential function. Okay. What's special about an exponential function and a log function or a logarithmic function is that they are opposites, or we like to call them inverse functions. Okay, so in other words, they are like opposites or reflections. Okay, so let's draw a rough graph of an exponential function first. So whenever you guys draw a graph, make sure you have your x and y axes, label x, y, and 0, no matter what. We know an exponential function has a asymptote, which is on the x-axis, where y is 0. When you guys draw in the exponential graph, we know that the exponential graph looks something like this. So you start very close to 0. Once you hit number 1, it cuts through number 1 and speeds up rapidly at an exponential rate. So that's your exponential graph. For example, always label a point. So let's say we sub x as 1 into this equation here. So we say when x is 1, y equals 3 to the power of 1, which is 3. Okay, so that would be 1, 3. Now, when you're drawing a logarithmic function, okay, so you draw your asymptote, your axes again, like this. Label x, y, and 0 always. See how in your exponential, your asymptote is on the x-axis? Because logs are technically opposites, guess where your asymptote is now going to be? It's going to be on the y-axis, like this. Okay, now for an exponential, see how it cuts through at 1 on the y-axis. Guess where it's going to cut through in the log graph? It's going to cut through 1 in the x-axis. Yeah, so if we were to draw this up, it would look something like this, very close to the asymptote. Once it hits number 1, it's going to ultimately bend over, but it's increasing at the same time. And there you go. That's your log graph. Now, if I was to combine the two graphs together, what you would see, we're going to draw a really rough picture here, is something, so y0x, that looks like this, roughly. So this is your exponential. Okay, then we have your log, which is like this. Okay, and then to tell if something is a reflection, we have technically y equals to x, and it's like a mirrored image, as you guys can see. So this here is your exponential, and this is your logarithmic function. Alright, now we want to see how far we bend the logarithmic function. So what you guys need to know is, we're going to draw another graph, something that looks like this. y, x, and 0. We're going to draw our asymptote for the logarithmic. So it's going to be on the y-axis. Okay. We're going to have our basic log graph. So we're going to say it cuts through number 1. So our basic log graph would be like this. Okay. We're going to give it any number. So y equals to log 3x, for example. Now, what you guys need to know is that if the number 3 gets a lot bigger, okay, so what's going to happen is if you graph it up, when you get older, so number 10 is a lot older than number 3, your back tends to curve a bit more, like you have a hunchback. Yes, let's just think of it like that. So you have a hunchback, so it'll look something like that. If you are younger than number 3, let's say if you're 1 year old, you wouldn't really have a hunchback. So it'll be something like this. And that would be another example of different types of logs. Yeah. Now, the question is, how do we know which point exactly to draw the log graphs to make sure that it is as accurate as possible? And my answer to you guys is the table of values. Okay. All right. So let's say I want to draw, I'm going to use the same example, y equals to log base 3x. Okay, from the previous lesson, what you have learned is that we are able to calculate the value of y when you know x. So substituting x as minus 2 into here, we know log base 3 minus 2 equals y. To find the value, you make it an exponential. Minus 2 equals to 3 to the power of y. So you just bump it up. The y goes to the power, the 3 goes there. There is no y value that can give you minus 2. Okay, so what we're going to do is that any negative number, it is completely impossible to have as a log value. What you can see in the graph is that for here, there are obviously no graphs here in the log section for the negative part, positive log. So we try x is 0, yeah? So log base 3, 0 equals y. Same thing, we are going to bump up the 3y. So with 3 to the power of y, we have 0. There is no y that can give you 0, which is an impossible task. Okay, moving on to the next one. Let's try number 1. So log base 3, 1 equals y. We bump up the 3. So 1 equals 3 to the power of y. We know that y can be 0. So 3 to the power of 0 is 1. So y is 0. Yeah? We can keep going like that. Number 2 is a little bit hard to use as a value. So we're going to try number 3. Because we kind of want multiples of 3 when you're looking at the question. So let's try that. Log base 3, 3 equals y. We're going to bump up the 3. So we have 3 equals 3 to the power of y. We know y has to be 1. Because 3 to the power of 1 is 3. So y is 1. Now we only have 2 values here. We kind of need to have 3 in order to draw a nice log graph. So I'm going to do a fraction, 1 over 3. So doing the same thing again. So we have log base 3. My x is now 1 over 3. Okay, equals to y. I'm going to bump it up. So 1 over 3 equals to 3 to the power of y. We know that 3 to the power of negative 1 will give you 1 over 3. So your y is negative 1. Now, when I'm graphing it up, we're going to draw your axes. Okay, so make sure you use a ruler. We have y, we have x. My ruler is not working on me, so that's my, x value, 0. We know that a log has an asymptote of 0 when x is 0. That means no function can cross through there. Okay, we have the first is 1, 0. So your x is 1, your y value is 0. Your next one, when x is 3, so that's number 2, then number 3, your y value is 1. Okay, and then when x is 1 over 3, your y value is -1. Since we have nice 3 dots, we can connect them. Okay, draw as neatly as possible. And there is your logarithmic graph. Okay, so what we need to know about this type of graph is that, first of all, we have an asymptote. Okay, so this is your asymptote. And your asymptote is when x equals to 0. Pretty easy? Okay, the limitations of this graph is saying that everything, all your x values, is on the right side of this graph. That means all of your x values has to be greater than 0. Okay, pretty easy.